I felt so bad. I didn't know nothing. I know. And we had to watch them and they that's the one on Friday.
Good morning. I didn't say that yet. Good morning. Good morning. Hello.
Good morning.
Aw, thank you. Thank you. I got two of
What did
you.
you think?
Hi's good also. Yeah. Yeah. Good point. Okay, so we're gonna do more with finding zeros. This will be our last day of this, and then tomorrow we are officially gonna do the type where I don't give you any zeros. So that's where the rational root theorem starts. But for today, we need to see what it looks like when we get more than one freebie. So for our first example, and I don't have a ton, I don't think you'll struggle too much with this today. Our first function is f of x, and he is 8 x to the fourth. You all right there, Hugo? Okay. Plus 48 x to the third minus 22 x squared minus 138 x minus 36. And this time there are going to be two freebies. So we're going to be given that f of -6 equals 0. And then we're also going to be given that f of -3/2 equals 0. So we're going to chop our way all the way down until we know how many answers will we get? 4. Very good, right? We know that going into this because it's x to the fourth. What's that? Right. So we're just looking for the other two, huh? So the question is, how can we use the 2 that we know to fish out the other 2 that we don't know? Anyone want to get us started? I know it's Monday. It's like first thing. Sorry, but yeah, I was wondering if anyone would spot that at 5 minutes into class on a Monday. But yeah, there is a greatest common factor. And I actually had not intended that when I wrote this problem, but bonus. So we can actually divide everything by 2. So when we go to set up our synthetic division, we can actually pull all of these numbers and divide them down by 2. And remember that when we so we can divide them all down. So when we set it up for synthetic division, let's just go ahead and take them all and chop them down divided by 2. So this one's actually going to become 4. And then what's the second one going to be? We're just dividing. Did I say divide them both? Divide them by 2, right? Is that what I said? 24. The next one? -11. Next one?
69.
-69.
Huge.
And then minus, yeah, let it go. Be done. All right. Minus what? Negative what? Very good. Yep. And now you have a choice. When you're given more than one 0, you can do them in either order that you want. It doesn't matter. And so you guys can decide, do you want to do the fraction first or the whole number part? Fraction first, get it out of the way, no problem. And the thing is, if they're both meant to work, they will work whenever you want them to. So you could do green then purple or purple then green. It doesn't matter. But Kaysen has made a choice for us and said, let's do the fraction one first. And so we're going to set it up. And outside, we're going to put our substitutor. In this case, -3/2. I feel like I think we practiced this quite a bit in the days before the weekend, or at least the day when there's a fraction. So drop the 4 and we begin. And then remember, you just keep hitting it with that hook method. So what's our first multiplier going to be? Good job, -6. And then when we add these together, we get 18, and then hit it again. What do you get? Yeah, -27. Good. And then add those together. What do you get? -38. Very good. And then multiply again, and what do you get? Yeah, nice work. It's a positive for sure. And then the 38 divided by 2 is 19 times 3 is 57. And then when we add those together, what do we get? -69 plus 57 is -12. And then when we hit it with our last multiplier, what do we get? 18. 12 divided by 2 is 6 times 3 is 18. There's our positive 18. And as we would have expected, we get a 0. Now, at this point in time, you have some options. Option number 1 is, again, look for a GCF, or option number 2 is just to dive right in. So it's up to you guys. I'm just going to show you on this example that what it looks like when we now do back-to-back synthetic divisions. This is our first time ever doing this. Is you actually just now build down off of these existing numbers and create like a staircase. And there might be instances in your math career where you staircase like 3 or 4 times, and it just goes from longer down to shorter, down to shorter. Every time you perform synthetic division, you essentially just shorten the problem by 1. But we can keep sort of piggybacking off of what we've already done. And the other free one is -6. Remember, that was from up here at the very beginning of the problem. So now we're going to go synthetic again, but this time we're going to use the other freebie, which is -6. So we're using the information that someone gave us to chip it down to where we can then get it down to Quadraticville, where we've got all sorts of options. All quadratics we are empowered to solve. Factoring, quadratic formula, whatever. So again, at that point, you could have divided those all by 2 if you wanted to. I just thought, let's see what it looks like if we don't, because getting the GCF out of these problems, I know it's hard for me to say this, it really isn't that big of a deal. It just makes your life a little bit easier, slightly smaller numbers. So we begin the process again. We just reset. And our first number is 4. Again, drop it down, and the algorithm repeats. What's our first answer going to be? And then after that, nice. After that, after that, after that, and there's our 0 as expected. Now we've run out of freebies at this point in time, but the freebies that we did have served the purpose that we wanted them to. They enabled us to chip 2 layers off of that 4th degree polynomial and bring it down to a quadratic, a 2nd degree polynomial. At this point in time, you would be wise always to pull the GCF. So, I mean, even though we didn't pull it up here, kind of where I'm moving my pen, that's okay, but we should get it now. Always get it at the end. So when we pull these 3 numbers down, the 4 is going to become a 2, and that is 2x squareds. And then the -6 is going to become a -3, and that's just x. And then the -2 is just going to be, of course, -2. And we're going to set that equal to 0. What are our options at this point? Maybe we could factor it. And in this case, yeah.
Divided by 2.
Yeah, that's my bad. Thank you. It's a good thing I don't keep track of my incidents anymore because of stuff like that. Thank you so much. Yes. And so at this point, we'd want to check and see if maybe we can factor it. And in this case, now that I've fixed it, now that you helped me fix it, the answer is no, it cannot be factored. And you could try it real quick if you wanted to. The only way it would be factorable, I wouldn't write this down if I were you, but the only way it would be factorable is if we did some combination like this. But the problem is with one of them having to be a plus and one of them having to be a minus, then it's not going to work. Like you're not going to wind up getting what you need. So having said that, Hopefully we agree, not factorable. So what's our backup plan when factoring fails? Yeah, I mean, for sure, the quadratic formula. So A is going to be 2, B is going to be -3, and C is going to be -1. Bless you. And so we go. X equals what goes first? 3 first, the opposite of B first, and then I'm ready for the plus or minus, and then put a big long square root. What goes first inside the root? 9. I think someone whispered. I'm not sure I heard it, but I think it was a 9. 9. B squared is 9. And then I'm going to put my -4. And then I'm going to put times something, and then I'm going to divide it all by 2 times A, which in this case is 4. And then I'm going to go back and fill in my spaces, which are A and C. And that's a 2 for A, and then a -1 for C. What's going to happen, and what are we going to get inside the square root there? 9 plus 8, right? It's going to turn to addition because the minus and the negative are going to hit each other. So at this point, the discriminant, it becomes 9 plus 8, which is 17. So this one is a pretty quick journey because we know that the square root of 17 is pretty much just dead trash. And so we can say x equals 3 plus or minus the square root of 17. And we can rest assured that there's no Dorito here, no reduction or anything. 17 has nothing to offer us at all. And then to complete your answer, you could put maybe a couple of commas like this. And then let's remember who our freebies were. We had x equals -6, I believe, was a freebie. And then our other freebie from the very beginning was -3/2. So x equals -3/2. So that's what's kind of new for the day, is the idea that if I give you more than 1 0, we use them in any order that we want, pulling out GCFs along the way if we want. Okay, it's all going to come out in the wash, but you're going to wind up with getting the answers that you need using the ones that you're given. And, we could do these where there's 3 given zeros or 4 given zeros. We're not going to, but just know that we could. So our next one is the function f of x, and he is 27 x to the 4th minus 72 x to the 3rd plus 54 x squared minus 24x and plus 15. And again, we've got some freebies. So we're going to start with f of 5/3 equals 0. And then we'll do f of 1. And again, just to be clear, I know I've said it, but like if Jordan and Mari were working this problem together and Jordan used the red one first and Mari used the green one first, their paths are going to look different, but they're going to wind up at the same quadratic. It's all going to work out in the end. You just have to decide, like, how do you want to do it? So what first? Yeah, they can all be divided by 3. So before we set it up for synthetic, it kind of makes sense to divvy them all up by 3. See if I can divide correctly this time. So 27 divided down makes a 9. 72, -72 makes a -24. 54 makes an 18. 24 makes a -8. And then 15 makes 5. Which one do you guys want to do first, red or green? What's that? Yeah, get the fraction done. Sure. You guys like fractions apparently, huh? So I'm going to stick 5/3 out here. And we begin. So we drop the 9 and we go. What's our first answer going to be? Yep. -24 plus 15. -9. Okay, hit it again with times. What do you get? Yep. Add them together. 3. 3 divided by 3 is 1 times 5 is 5. -8 plus 5 is -3. Okay, cancel it out. Swing it down, divide, multiply, you get -5. And then, of course, we knew this was coming. Okay, at this point in time, you can again just staircase it down, or if you wanted to, you can divvy them all. Let's try just plopping out the GCF a little early this time. So instead of, building the staircase like I did last time, this time I'm going to go ahead and just divide them all before I begin. So they can all obviously be divided by 3. So we're going to have a 3 and a -3 and a 1 and a -1. And then we're going to build another synthetic division. And this time we're down to the green one, which is 1. So we're going to synthetically substitute the number 1. And here we go again. And we know that there should be a 0 down here. So as I've said before, you're welcome just to sort of put it in there. You're working towards that, right? So if we drop the 3, there we go. 1 times 3, 3, add them together, 0, 0, 1, 1, 0, boom. So we did it. And again, you should understand that right now you sit here and you could say, I can solve literally any quadratic in the world. With the quadratic formula in your back pocket, nothing's off limits. This one's not going to require the quadratic formula. We have a different tool for this. We learned it on, I think, Thursday. So when I pop these numbers down, they're going to be 3x squared plus 1. And you might recall from Thursday that this is that special kind of flavor of quadratic, right? This doesn't, I mean, you could use the quadratic formula, quite frankly, with 3, 0, and negative, or 3, 0, and 1, if you wanted to. But we have a different way to do this. What is it? Do you remember how to solve these little baby quadratics where they're missing the b term?
Oh, the 1.
Subtract the 1 first. Good job. So we have 3x squared equals -1. After that, divide by 3, and we wind up with x squared equals -1/3. All right, so we're poised for the final move, if you will. And what is the final move? Square rooting this thing, both sides. And so we get x equals. We always put just positive, negative before we forget. And then we consider the roots of the top and the bottom. What is the top going to be? Yeah, the top is actually just I. Remember that by definition, when you take the square root of -1, it's just quite literally I. And then what's the bottom going to be? Root 3. Okay, and why do we hate this answer? Because you can't have roots on the bottom, right? So we do that thing that we learned called rationalizing the denominator, where we take the fraction and multiply the top and the bottom by the root that's causing us grief. So in this case, we're going to multiply the top by root 3 and the bottom also by root 3. And put little time signs in there. And then what do we get now on the top? Uh-huh. I. And then what do we get on the bottom? 3. Good. Remember that when you multiply root 3 by root 3, you just get 3. So there we go. We did it. We rationalized the denominator. So at this point, we're going to make a list of our answers. And going all the way back to the beginning, we know that, so we were given x equals 5/3. We were given x equals 1. And then, of course, we just discovered that x can equal the positive or the negative of I root 3 over 3. And there's our answers, right? 1, 2, 3, 4. I got one more, and I don't remember. I wrote these on like Thursday, so I don't remember what the inspiration was for this example. But if I put it on here, there must have been a reason. I was trying to do examples that would prepare you for the assignment today, so this one must have something to offer that the others did not. So any questions about this so far? Repeated synthetic division is kind of fun. I mean, you kind of have to be a mathy nerd to appreciate that, but it's kind of fun. So anyways, our last function before we get to the assignment is f of x equals 36. X to the 4th plus 48. X to the third. Yeah, my bad. I almost misread that. Minus 77. X squared minus 62x and minus 8. And our freebies this time are -1/6 and -2. All right. What do we do first? To start, yeah, there is no GCF this time. The 77 really gets in the way there. And 77 has factors of 7 and 11, but 7 or 11, neither one of them goes into anything else. So at that point, we're like, let's just go. All right, so it's time to do our synthetic division. So we have our numbers 36, 48, -77, -62, and -8. And we're going to upside down division. And again, you guys want to go fraction first again or fraction second? Just get the fraction done. I like it. So stick the fraction out here and we're off. And if this math is still something that you're struggling with, I can try to help you. Just need to continuously remind you that you're just dividing by the bottom and multiplying by the top. That's all it is. So what's this first one? -6. Okay, add those together. What do you get? Perfect. Multiply. -7. Add those together. -84. Okay. Getting outside our comfort zone here. 84 divided by 6 is 14. So in this case, it is +14 because it's a negative times the negative. -62 plus 14. It's definitely still negative, right? It is -48. And then when we synthetically, or not synthetically, but when we divide and multiply, hook it, 48 divided by 6 is 8. And it is a positive because it's a negative times the negative. And hey, surprise, surprise, we got a 0. Anyone see a GCF? Yeah, good job on that one. Great observation. I don't know if you guys would have spotted that, but thank you for the help on that. These numbers can all actually be divided by 6. And so, say again?
We did divide. Yeah, when we were synthetically, I think we wrong, but this will be by 6.
Yeah, that's deep, dude. I like that. I like that kind of thinking. There's like zero math.
Yeah, but look what we divided by, and then you divide that by 6.
What he's saying is that and I appreciate in all of my years of teaching, no one has ever made that observation before, that these numbers that I'm circling in red, by definition, all have to be divisible by 6, because in the synthetic process, well, we kept dividing them successfully by 6. I was right there with you, Kason. And I think it's a gorgeous observation to have made. So I always appreciate that. That just shows you have zero anxiety about mathematics in your brain. That's a telltale sign right there. Just thinking outside the box. Nice and casual and relaxed. So if I divide these all by 6, I get 6, 7, -14, and -8. Love that perspective. That was cool. And then our other freebie is up there in the corner, but I'm about to make it go away. Remember, it was -2. And so now we begin the process again, but with -2. And I think that was my green guy. So I'll put -2 and we're off. Drop the 6. -12, add -5, multiply 10, add -4, multiply +8 and get a 0. And these numbers right here are not divisible by anything. 6, -5, and -4 are pretty relatively useless, right? So at this point, seeing that they can't all be divided, we go ahead and just construct a quadratic. 6x squared minus 5x minus 4. And sitting here looking at it now, I remember why I wrote this problem. What do you think? I've tried to teach this to people before, but no one is interested until it's time. And it's time to show you something. Only about 6 of you will be interested in this. The others of you, it will be of no use. But if you're interested, I would sit here right now and say something like, boy, I sure wish I knew if this could be factored without wasting my time. So here it is, a trick. Take it or leave it. If I try to teach this when it's not appropriate, then it just falls on deaf ears. But at this point, you should want to know, could I factor? And the answer is, well, let's find out. You take the number in front and the number in back, and you multiply them. What do you get? Negative 24. Are there numbers in the known universe that add to make, or that multiply to make negative 24 and add to make negative 5? 8 and 3, negative 8 and 3, right? So the fact that those numbers exist means that this is factorable. So using those numbers, and I'll show you what I mean. So remember, they have to multiply to make negative 24 and add to make negative 5. And I mean, by this point, you'd already be rocking through the quadratic formula, so whatever. But the numbers that multiply to make the top and add to make the bottom are positive 3 and negative 8. Do we all agree with that? So what we're going to do is we're going to take the term in the middle and we're going to break it up in half. So we're going to write this as 6x squared plus 3x minus 8x minus 4, like this. There's a decent chance that you're pretty lost right now. So let me just slow down and explain what just happened. I just took the term that I circled in red and I broke it into 2. But I didn't arbitrarily just pick two randos that add to make negative 5. I was very deliberate in picking the numbers that work to satisfy the thing we were talking about. Those 2 numbers that I just broke it into multiply to make the product of the ends, and they add to make the middle. And so now we can do grouping on it. And if this is losing you, then just ignore it and just know you could have factored it and you could get down with your trial and error bad self. It doesn't matter. So what's the GCF of the first 2? 3x, which leaves behind 2x plus 1. And then what's the GCF of the back half? Negative 4, which leaves behind 2x, change the sign, plus 1. So my factors are 3x minus 4 and 2x plus 1. And then finally, we can finish the problem. There's a very high probability that everything that happened inside of this green bubble was really confusing for you. It's because I don't teach factoring that way. I just thought in this case, I'd throw it out there and see if it sticks. So if that completely vexed you, don't sweat it. You could have just factored like you always did. So anyways, the answers, it's time to spit out the answers and then it's time to get to work. So we're going to take this one first. That gives me an answer of what? X equals? No. Positive 4/3, good. And then how about this second guy?
Negative.
Now that's a negative, very good. And then we had some freebies, right? X equals negative 1/6 was a freebie. And then X equals negative 2 was also a freebie. And that, my friends, is that. So there you go. So your assignment is number 15, and it's on Canvas, but it's just not quite there yet. It'll be there in about 30 seconds because I need to quick publish that Canvas page for you. But that is that. I'm going to pause this, and then in case anyone has any questions.